All right, guys, welcome back. We're going to do lesson 92, expanded notation with exponents, order of operations with exponents, and powers of fractions. So we'll go through each of these three sections just in order. So make sure you have your book, and we're starting on page 479. 479. Also make sure, again, that you have pencil and paper. Follow along with taking notes and listening and looking in your book, okay? So we'll start with mental math. Again, that's on page 479. And today what I'll do is I'll write out the answers so you know that you got them correct. So letter A is 30 times 50. And you'll notice that this time they're using that dot to represent multiplication instead of the time symbol that we're used to in the form of an X. So 30 times 50. Just like the previous lesson, if you need more time, just pause the video, but we're going to go right through the answers. So 30 times 50 is 1,500, or 1,500. Letter B, 486 plus 50. 486 plus 50 is 536. Letter C, 50% of 24. What is 50% of 24? And the answer there is 12. Letter D, we have $20 minus $14.75. So think for a minute, what's $20 minus $14.75? The answer is $5.25. Naturally, this isn't enough time to really do these problems, so if you need to pause it, like I said, please do so. Letter E, 100.
I can look.
100, I don't know what I just pressed to do that, times a 1.25, or remember the technical way we read these would be 1 and 25 hundredths. So what's 100 times 1 and 25 hundredths? And the answer is 125. Letter F is 600 divided by 30, or 630ths. The answer to this one, so it's just division. Remember that fraction bar represents division, is 20. And then an algebra question for letter G. It says in algebra, if n equals 3, what does 5n equal? If n equals 3, what does 5n equal? So you just substitute that value 3 in for n. 5 times 3, 15. And letter H, I'm not going to write this one out. It's a mental calculation. I'll read it. And remember, this isn't order of operations, because if you look in your book, there's a comma after each operation. So you just do it as it said. So we have the square root of 36 plus 4 times 3 plus 2 divided by 4 plus 1, and then find the square root of that. And the answer you should come up with is 3. All right, so good job on those. And we're just going to get right into the lesson otherwise. So I'm going to erase these. Didn't need to take notes on any of that. That was all supposed to be mental. Okay, so the first part of this lesson is expanded notation with exponents. And we've already done expanded notation in the past. And I will show you an example of that. 365 in expanded notation. So you take each digit and multiply it by its place value. So 300 is in the hundredth spot, so we multiply it by 100. Then we're going to look at our next digit. 6 is in the tens place, so it's 6 times 10. And then finally 5. 5 is in the one spot, so it's 5 times 1. And that's general expanded notation. But today we're going to write our powers of 10 with exponents. So in this case, we're going to look at the same number, 365. Instead of writing 100, we're going to write 10 squared. So 10 to the power of 2, or 10 times 10 is 100, so we're just going to write it this way. 6 times 10 to the power of 1, and then 5 times 10 to the power of 0. Now you need to note that 10 to the power of 0, oh no, 10 to the power of 0 equals 1. And really any number to the power of 0 equals 1. So write it down or mentally remember any number to the power of 0 equals 1. And then if you look in your book on page 479, you'll see this table, and it's whole number place values using powers of 10. And I just brought that table in here for us to look at. Oh, yikes. Someone's driving by fast. All right, so whole number place values using powers of 10. So it goes through all of the ones places, the thousands, so 10,000, 100,000, millions, billions, and trillions, showing you what those digits would be, or what the powers of 10 will be with exponents in those place values. So say we had a number like 3,475,000. We'll just do that. So if we wanted to write this in expanded notation using our powers of 10, we would do 3 is in the million spot. So what is a million? You can look on this. 10 to the power of 6. Plus 4 is in our 100,000 spot. What's the power of 10 in 100,000s? 10 to the power of 5. And then our thousands spot. Ooh, I skipped one. Sorry. Our 10,000s. We've got a 7 there. 10 to the power of 4. Ran out of room, so I'm going to write it down here. And then 5 times 10 to the power of 3. All right, so that's basically what we're doing in this part of the lesson, is we're using expanded notation to write out our digits, and we're also using our powers of 10s with exponents. So write this table in your notes, or just get familiar with it. Another thing to note is that really what we have here, let's look at this one for example, 1,000 in the tens place. So 1,000 can be written 10 cubed, or 10 to the power of 3. So what that really means is 10 times 10 times 10. But once we get into, like, say, the 100 trillions, you're not going to do 10 multiplied by itself 14 times. So sort of a little quick way to do powers of 10 to exponents is write 1, and then this number represents how many zeros we have coming after it. So 10 to the power of 6 is going to be a 1 with 6 zeros. All right, so based on that, it should be 1 million. Check your table. 1 million is 10 to the power of 6. Okay, so make sure you take note of that. So these, when we have powers of 10, it's 1 with this many zeros. Make sure that it's 1 with however many zeros the exponent is, not 10. If you do it that way, you'll be a place value off each time. Okay, so we're going to look at our first example there. I'm going to zoom out and erase some of this. If you need any of this, pause the video or go back and write some notes. But we're going to look at our first example, and you'll find that example on page 480. So make sure you're following along. We're on page 480 now. Example 1 says the speed of light is about 186,000 miles per second. Write 186,000 in expanded notation using exponents. So what we're going to do is we're going to write each digit, each non-zero digit, and we're going to multiply it by its place value as a power of 10. So 1, what place is the 1 in? It's in the 100,000s place. So you can look on your chart and say 100,000s is 10 to the power of 5. Okay, your next one, so plus your next digit is 8. That's in the 10,000 place. So 10,000s, 10 to the power of 4. Plus 6. What place value is our 6 in? It's in the thousands place, so 1,000s. 10 to the power of 3. And then, as I mentioned, you don't have to write non-zero digits, or 0 digits. So, just because we know anything multiplied by 0 is going to be 0 anyway. So you can sort of exclude that one. So, I can't really ask you if you have questions, but if you have questions, you'll have to leave a comment for me. But hopefully this makes sense. So you write your digit and multiply it by its place value in terms of powers of 10. You know what? Let's do one more just in case. I don't want anyone to get confused. Let's do, I'll just make up a number, 5,036. Okay? 5,036. So even though we have a 0 between some non-zero digits, our process is going to be the same. So look at your first digit. In this case, it's a 5. What place value is in the 5? Is the 5 in? It's in the thousands place. So look at your thousands. How do we write that in terms of a power of 10? It's 10 cubed. Plus, we don't have to write our zeros, so I'm going to skip that. Our next non-zero digit is 3. What place value is the 3 in? It's in the tens place. So I'm going to write 10 to the power of 1. And then our last digit is a 6. What place value is in the 6 in? It's in the ones place, so I'm going to write 10 to the power of 0. Recall from the beginning of the lesson that 10 to the power of 0 equals 1. Okay? Hopefully that helps. We've done expanded notation before, but now instead of just saying 5 times 1,000, we're writing 1,000 in terms of a power of 10. So, let me know if you need help with that. We're going to have a practice set problem on that in just a little bit, so hopefully that will go well. Otherwise, we're going to carry on to the next part of this section. Like I said, pause, go back, ask a question in the comments of our Google Classroom. So part 2 of this is order of operations with exponents. Nothing really new here either, but let's go over the order of operations quickly. So one thing about the order of operations I'll actually talk about in a second when we're looking at an example, but I did see some confusion on your last test about the order in which you do things. Let me write an example. 3 times 3 plus 3 divided by 3. Okay, we'll do that problem after we go over the order of operations. So remember, P stands for parentheses. Any work in parentheses is done first. E stands for exponent, so that's what we're doing now. M and D stand for multiplication and division as they are encountered from left to right. So remember, as you're reading across the problem, whatever you see first, if it's multiplication, do that first. If it's division you see first, you do that. And then same process with addition and subtraction. You'll do whichever one you encounter first as you go from left to right. So in this example problem, we have a multiplication, an addition, and a division problem. Consult order of operations if you don't have this memorized yet, and you'll see we need to do our multiplication and division first as encountered from left to right. So first we see 3 times 3. So you need to do that. My suggestion if you have problems with order of operations is to, I don't know why I wrote it like that, is to write out each step, because what I've seen people do is they know that the next step is division, so they'll do 9 divided by 3. They'll skip around the problem, but you still need to do things in order. That's why it's order of operations. So our next problem would be 3 divided by 3. All right, you don't just take the answer to this and do the next part of the order, okay? Don't do that. Rewrite the problem, write out the steps. So you do your division next, and 3 divided by 3 is 1, and then finally we'll do our addition, and we would get 10. So you guys know my laptop is touchscreen, so that's why all these extra markings are happening. That's okay. So that's a brief overview of order of operations, but now what you're going to see is some sample problems when we actually will have parentheses and exponents. So if you're looking at example 2, still on page 480, we have 5 minus, that's a division symbol, hard to see. So we've got a lot going on here, so it's really imperative that you understand ordered operations. So look at our list. If you want to write this down, I suggest you do so. What do we do first? Parentheses. So that's what we're going to do first. We're going to do our parenthesis problem first. And we're not even going to worry about anything else yet. Some of you understand this already. Great. Carry on like you normally would. If this is confusing to you, if you're getting these problems wrong, write out each step. That's what I like to do. Okay, great. Parentheses, done. Next, exponents. Now, when you see exponents, it's also going to have you do any of your problems with roots. So we'll do any of our square root problems as well, which you'll see here we have a problem, and then here we have an exponent. So we're going to do those. We're going to evaluate those. What is the square root of 16? Remember, that means what times what equals 16, and that's 4. Plus 3 squared. Remember, that means 3 times 3. All right, so that's 9. So I like to write these out. Next, multiplication and division as you see them from left to right. So there's division here, multiplication here, but we're going to do this part of the problem first because we encounter it first from left to right. So 5 minus 16 divided by 4. And I'm just going to write out each step. I don't want anyone to get confused. Next, we'll do our multiplication. So rewrite these. We're not skipping around. We're still going in order. 9 times 2. And then addition and subtraction from left to right. So first, we're going to do 5 minus 4 because we see that first. And then finally, our last addition, and we get 19, all right? So there were a lot of steps to this problem. So if you're not using order of operations appropriately, you will get incorrect answers. So make sure that you are getting that down. If you need help, let me know. Let your parents know, siblings, whoever may help you. So if you're also looking in your book, they sort of combined that multiplication and division step into one step because these problems are separated. So they did this one and this one sort of in one step instead of writing it out twice. But do whatever works for you to get the correct answer. Okay? All right, that was the second part, order of our operations with exponents. We're going to move on to our third part, which is powers of fractions. So basically what this is we're taking fractions now and giving them exponents or raising them to a power. So 1/2 cubed can be written or understood in two different ways. The first, just like any of our powers, means we're taking that number and multiplying it by itself this many times. So 1/2 multiplied by itself 3 times because it's 1/2 cubed. Another way to understand it is that each term in this parenthesis, each term of the fraction is going to be cubed. So it's 1 cubed over 2 cubed. And that's one of the reasons why we usually write parentheses when we're talking about a fraction raised to a power. So we're multiplying fractions. What do? We just multiply across 1 times 1 times 1 over 2 times 2 times 2. Or what is 1 cubed over what is 2 cubed? Right? 1/8, either way. So you can write these either way, but I want you to understand it in both ways. So this means we're taking that fraction, multiplying it by itself this many times, or we're sort of distributing that power to each part of the fraction, to the numerator and the denominator. This also works for decimals. So if we have 1/10 squared, it means 1/10 times 1/10. So make sure you recall how to multiply decimals. We multiply them, so 1 times 1 is 1. And then we determine decimal places. So we have 1 decimal place here, 1 decimal place here. So that means we need to have 2 decimal places in our answer. So 1, 2, we would get 100th or 0.01. Okay, so our powers with fractions apply in the same way here. Example 3, now on page 481, it says 2/3 squared. So what does this mean? 2/3 squared. It means we're taking this factor and multiplying it twice, or if you want to think of it this way, 2 squared over 3 squared. Either way, you're going to get the correct answer. So multiply across 2 times 2 over 3 times 3. Okay, so you should get 4/9 there. 4/9. Okay, we're going to work on our practice set next. So that's on page 481, practice set. Page 481. Let's do A through G. So pause for a moment, work on those problems. I'm going to start writing them out and prepare to go over the answers. All right, hopefully you paused the video because I'm just jumping into the answers now. Letter A says write 2,500,000 in expanded notation using exponents. So recall here that you just need to write your digit and multiply it by the power of 10 based on its place value. So 2 is in the millions place, so that is 10 to the power of 6. Plus, next we're going to write 5, so let me write the original problem here as well. 5 is in the hundred thousands place, so that's represented by 10 to the power of 5. And really that's it for that problem since the rest of the digits are zeros. So we're done. 2 times 10 to the power of 6 plus 5 times 10 to the power of 5. Next, write the number in standard notation. So they're giving us 5 times 10 to the power of 9 plus 2 times 10 to the power of 8. So you can either consult the table in the beginning, or if you wanted to just remember that that's going to be, this number is a 1 with 9 zeros. So 10 to the power of 9, you'll see, is in the billions place. So it's going to be 5 billion. And then 10 to the power of 8 is in the hundred millions place. And since there are no other digits given, we understand them to be zeros. So 5,800,000,000 written out in standard notation would look like that. Letter C, simplify. So they're asking us to use order of operations, and maybe I'll work this problem over here. 10 plus 2 cubed times 3. I didn't give myself enough room. 10 plus 2 cubed times 3 minus 7 plus 2 divided by a square root of 9. So this is a plus sign, even though it doesn't look like it. So order of operations, PEMDAS. What do we do first? Parentheses. What's 7 plus 2? 9. Next, E, exponents and roots. So we're going to evaluate 2 cubed, so 2 times 2 times 2, and the square root of 9, pardon me, which is 3. Okay, next, these next few steps are really important because the order matters. We're going to do multiplication and division as we see them from left to right. So first we encounter 8 times 3, and if you want to at the same time, as long as you're not getting yourself confused, you can also do 9 divided by 3. Because they're separated by the subtraction sign, we know we're not going to mess up the problem. So 8 times 3, 9 divided by 3. So that's where we're at now. And now we're going to work our addition and subtraction from left to right. So what's 10 plus 24? What's 34 minus 3? 31. And that should have been your answer for letter C. So those of you who are more comfortable with order of operations, you probably didn't want to go over that, but it's okay. Some of us need to remember those steps. So I'll keep the answer there, 31. Letter D is 1/2 cubed. Remember that's 1/2 times 1/2 to 1 times 1/2, which we've already evaluated to be 1/8. Go over this one again. So you multiply across, even though we have more than one factor now, we still multiply across our numerators and multiply across our denominators. Okay? Letter E is one we also evaluated already in the lesson. It was 1/10 squared. So that means 1/10 times 1/10, which you should get 1/100th or 0.01. And then this next one, we actually didn't do an example like this in class, but we have 1/2 squared. Remember, when you're multiplying mixed numbers, you'll want to first turn it into an improper fraction. So turn 1/2 into an improper fraction. Evaluate it. I'm going to write this one a little differently since we've already done one fraction problem the other way. So I'm going to sort of distribute that power to the numerator and denominator. So then evaluate what is 3 squared over what is 2 squared, and then turn that back into a mixed number. So we would get 2 1/4. Right, so before you do your exponents with mixed numbers, change them to improper fractions. And finally, letter G is sort of putting some of these things together. So we have 2 plus 3 squared minus, and notice in parentheses here it's a little different, 2 squared plus 3 squared. So order of operation says parentheses, exponents, multiplication and division, addition and subtraction. So it's going to look a little confusing here. Do your work in your parentheses first. So in our parentheses we have 2 plus 3. What is that? 5. So we've evaluated that. Now our work in parentheses here is going to take a few more steps. It's 2 squared plus 3 squared. So within our parentheses, we're now re-following the order of operations. So we don't have a second set of parentheses here. So we are going to work with our exponents before we do addition. We're going to do exponents before addition. So you need to evaluate what is 2 squared, what is 3 squared. Okay? Notice that we still have a set of parentheses here that we need to work through. So I'm going to rewrite this step because we're not to exponents yet. Then we have in parentheses 4 plus 9. So now you can evaluate that. So in our main order of operations, we've done parentheses. Now we have to do exponents. So you can evaluate 5 squared. No multiplication or division, so we can skip that step. And then we move right into addition and subtraction, which really all we have is 25 minus 13. So do that problem, and you should get 12 for letter G. 12. All right, so that was lesson 92, and now I'm going to assign your homework. So homework is on page, I don't know what that is. Please go away. Page 481. I'll just write this on a new page. Homework 481, 5 through 7, 11, 17, 20, 22, and 26 through 29. Make sure you did that practice set, and then you can move on to your homework. If you have questions, leave them for me in the comments. Or email me, whatever you need to do to get a hold of me. So I hope that went well for you guys. Feel free to go back and listen over the sections that maybe didn't make as much sense. And thank you guys for listening, and